Hello everyone. Today we will be presenting our project which focuses on creating a personalized content recommendation system specifically designed for digital streaming platforms like Netflix. As we all know, streaming platforms cater to millions of users, each with unique tastes and preferences. A key challenge they face is keeping users engaged by recommending content that aligns with their interest. The goal of this project is to enhance the user-centric experience by predicting viewer preferences based on the behavior and delivering highly personalized recommendations, not just by suggesting popular titles, but rather understanding what each user is likely to enjoy, even if it's something they haven't considered before. So, streaming platforms like Netflix thrive on delivering personalized content to millions of viewers. Without accurate recommendations, users may lose interest, potentially impacting subscription rates. Our project addresses this by building a machine learning based recommendation system that leverages advanced text analysis. The techniques we have used in this project are TF-IDF vectorizer and bag of words to extract meaningful insights from textual data like descriptions and titles. Word to vector to understand the semantic relationships between content features. Exploratory data analysis to identify patterns, trends, and correlations that guide our recommendation strategy. And also we had used semantic search and LDA algorithms. For this project, we used a dataset source from Kaggle that contains information about Netflix content library. The dataset provides comprehensive details for movies and TV shows, including attributes like title, genre, director, cast, etc. We can see the overview of the dataset. The total number of entries are around 8,800 plus, with movies being the major part of the content. Thank you. Now my teammate will continue.
Next, we begin by handling columns with missing values. The two most significant columns with missing values were country and rating. The country column was addressed by calculating the mode for each genre, while the rating column was resolved by referring to external sources for movie ratings. During the exploratory data analysis, we created a new genres column from the listed in column and performed basic descriptive statistics to get hold of the data. Next, we move on to visualizations. The visualizations on this slide provide insights into the content on the content distribution on the platform. The first chart highlights the top 10 countries contributing the most content, with United States leading significantly. The second plot shows the distribution of the content ratings, with R and TV14 being the most common. The third graph reveals that movies dominate the platform compared to TV shows, showcasing a strong preference for cinematic preference. Next, these visualizations provide insights into content trends. The radial plot shows a surge in content additions during the holiday season. The heat map highlights correlations among genres, such as strong correlation between action and international genres. The stacked bar chart on the left emphasizes variations in movie and TV shows contributing across countries, with India leading in movie dominance and South Korea focusing more on TV shows. Next on this slide, we have average release years versus addition years of TV shows and movies across different countries, which showcases that the most content was added around 2020 and 2021. Moreover, on this slide, we have genre popularity by region, highlighting how drama and comedies dominate globally, with United States contributing the most across genres. The second visualization depicts a steep rise in the content production post 2000, with international movies and dramas leading in recent years. Here, our hypothesis that genres are most popular among specific regions is true, whereas the hypothesis that there are identifiable patterns for increase in production for specific genres only is false. Next, we look into content recommendation methods. These methods are important as they recommend similar movies based on their content. The goal is to identify correlations between movie attributes, user preferences, enhancing the recommendation system for better user engagement. Here, the first method we use is the TF-IDF method. Our implementation preprocesses movie data, creates a TF-IDF matrix of combined attributes, and computes cosine similarity to recommend movies based on the user selected titles. Next, my teammate will highlight the other methods.
The next model we used is the bag of words, which works by creating a vocabulary of all unique words in a dataset and representing each document as a vector based on word frequency. The model simplifies the text by representing each movie's metadata as a collection of words, and in this case, we combine the features like title, cast, genres, and description into a single text column. And we have initialized a count vectorize that used to create a document term matrix where each movie is represented as a vector based on frequency of unique words. And by using cosine similarity, we compared these vectors to measure how similar movies are based on the shade terms. And this approach worked well because the Netflix structure metadata enabled the keyword overlaps and making it computationally efficient to recommend movies with related themes, genres, and cast members. And the strategies that worked here for the success were the combined key text features that helped us to get into a single representation, and we also leveraged the cosine similarity to compute the movie similarity effectively. And we also used the word to vector, which represent words as a dense numerical vectors in a continuous space, capturing the semantic and contextual relationship between the words. And how it worked for our data set, we used it to capture the semantic relationships between the words in the data set. The metadata like the genre, cast, and the description were combined, and we all used it to tokenize to train the word-to-vec model. And each movie was represented as a dense, 100-dimensional vector embedding that preserved contextual relationships. And also by using the cosine similarities, these embeddings were compared to identify movies with shared themes or attributes. The method excelled in finding the connections, such as the movies with the similar storylines or cast members, providing personalized and highly relevant recommendations for the users. And since we use the tokenized rich metadata, we had a better embeddings, which helps us in the strategical success. And we also use the cosine similarity to rank the movies based on the semantic closeness. And the other model that we use is the LDA, which is usually used to uncover the hidden topics within a collection of documents by identifying patterns of word usage across the dataset. And the features like the descriptions and the genres were combined into a single text column. Then we have vectorized it into a document term matrix. The LDA model identified 10 distinct topics with each movie assigned to a dominant topic based on its content. And the recommendations were generated either by matching the user input, like a thrilling action movie with horror, to the most relevant topic or by suggesting movies that shared the same dominant topic. While the LDA helped categorize movies, it also struggled to capture the finer nuance in the dataset, leading to less personalized results compared to the other methods. And the reason why it was less successful was the thematic topics generated by the LDA were often too generic and grouped unrelated movies under the same topic. And it also lacked precision for personalized recommendation as the probabilistic topic distribution didn't always align with the user specific inputs. And my teammate will continue from here.
Next, we will talk about semantic search. So in our current semantic search implementation, we use a sentence transformer model that is the all mini LM L6 version 2 as the core engine. The process involves four key steps. First is converting the key descriptions into embeddings. Next is encoding user queries into the same embedding space. Third is calculating cosine similarity between queries and the final content. And then finally ranking the recommended contents in the top five. This creates a sophisticated embedding space where like similar content clusters together and then enables contextual understanding beyond simple keyword matching. And we can also see it from the graphs shared. Next, I will show the demo of the project. So for that, the current interface that we have built is based on Streamlit, and it combines multiple recommendation methods as we talked about before, and kind of offers a clean, user-friendly design. Users can input their preferences and the system then processes these through various algorithms and then provides the recommended content that we can watch on Netflix. So I can show you once. This is the TF-IDF recommendations. Next is the low-end recommendations. This is used by the graph clustering. This is bag of words recommendation. We have also word to vec recommendations. And we are also showing the semantic search recommendations at the bottom. Now, if we talk about the future scope of our project, we can enhance the user experience further by making several improvements, implementing dynamic user input features, and this would allow user to get more nuanced preference selection. Visual upgrade could also be made that would show the graph community selection from low-gain algorithm, and heat maps as well as other visual tools can also be introduced that would help the users better understand via the recommendations they are getting. If we look at the technical side of it, advanced NLP techniques can also be implemented, like uh, a better sentiment analysis could also provide us more better recommendations, while the technique called name entity recognition can be used that would help us search the content based on actors and directors in the cast, basically. Additionally, we can have topic modeling using bird topic, basically to get the content categorized and displayed into the main themes for the recommended movies. A collaborative filtering approach could also be used and incorporated. This would allow the system to learn from the user history and preferences, thus making the recommendations more personalized over time. These enhancements could transform our system into a more comprehensive, intelligent, and user-centric recommendation platform, and thus providing a richer experience for movie enthusiasts. Thank you.